Good day guys, welcome back to the King Tutorial class and welcome to another series of differentiation in calculus. Now, so our last class we treated differentiation using function of function. Okay, now in this class we're looking at product rule and quotient rule. Okay, in differentiation. Now, in which case I'll be starting with product rule, then now go on to quotient rule. For product rule formula is what? The y dx equals to what? V du dx plus u dv dx. That is product rule. So how can I use product rule to answer questions in calculus? Let's see how it goes. Example 1. Given that y is equals to x into bracket x minus 1 all squared, find dy dx. In this case, we're going to use product rule. Why? Because we have two functions multiply themselves, which are x and what? X minus 1 all squared. Let's see the way it goes. For example 1, y is equals to what? X minus 1 all squared. And from our formula is what? The y dx equals to what? V du dx plus what? U dv dx. Which implies that what? V and u must appear in my what? In my solution. So since this is a plus sign in formula of product rule, then it implies I can make any of them u and any of them what? V. So, but let's make this first one u, let's make second one v. Okay, saying that let u be equals to what? X, and what? Let v be equals to what? X minus 1 or what? All squared. So now the idea is to what? Get our v, which is this. Okay, next we have to get our what? Du dx, which we're going to get now. Then get our u, which is this, and get our dv dx. So from here, well, let's find out what du dx. Du dx in this case is what? Is 1. Okay? And for this case, dv dx, now this is a question that you likely use function of function to solve. Okay? Where we make this one in the bracket a particular variable. Okay, as I said, we can use any variable of your alphabet apart from u. So let's make this place a. So let a be equals to x minus 1. X minus 1. In which case, the a in this case now, the x is going to be equals to what? It's going to be equals to 1 minus 0. Why? Because differentiating x, you're going to get 1. Differentiating 1, we're going to get what? 0. So therefore, my dA dx is what? dA dx is what? 1. Now, since we said a is equals to x minus 1, v now will be equals to what? A raised by what? 2. Differentiating v with respect to a, the v dA is going to be equals to what? 2a. That's 2 times a, then 2 minus 1 as for our formula. That's what? That's 2a. So, after getting this, I need to find what? My dv dx. Okay, I'm not looking for dv dA, I'm not looking for dA dx. So I have to find dv dx in this case. Then I will add it to this and get my answer. So, how will I get my dv dx in this case? dv dx using function or chain rule is going to be what? dv dA times what? dv dx, which is now equals to what? dv dA is what? 2a times dv dx, dA dx, I mean. Sorry, this is dA dx. Then dA dx is what? 1. Now, leaving our answer to what? 2a. So, this is my dv dx. So, I can now apply dv dx and du dx into the formula of dy dx to get what? The differential of this question. In which case, dy dx now becomes what? V comes first. So, the value for our v is what? X minus 1 all squared times du dx. Du dx is what? Du dx is 1 plus, okay, from our formula, u is what? X. Okay, times what? dv dx is what? 2a, where our a, forgot to put, our a is what? X minus 1. So our a is 2x minus 2 in that case. 2x minus what? Minus 2. So dy dx now becomes what? X minus 1 all squared when multiplied with 1 plus what? 2x squared minus what? Minus 2x. So expanding this, I can have that as what? X squared minus what? 2x plus what? 1 then plus 2x squared minus 2x. In which case, after collecting the items, I'm going to have that as 3x squared minus 4x plus 1. So this is my dy dx. Also, you can leave your answer in this form. Okay, possibly after collecting the like terms there, or you can expand it to this form. Depends on how the question asks. Given that y is equals to 3 into bracket x plus 1 all squared, then times x minus 1, find dy dx. Now, whenever you see any question in mathematics, generally, okay, you need not to be scared. Okay, what you just need to do in that case is to what? Apply the idea you know and see how well it can get you. So for this case, I'm going to be applying product rule. Okay, making this our u and what? This our what? Our v. So let's see. Let u be equals to what? 3 into what? X plus 1 all squared. And let v be equals to what? X minus what? X minus 1. For u, I'm going to be using what? I'll be using function of functional theory to solve this. Okay, so the same way we did it for example 1, let a be equals to what? X plus 1. I want to solve for you now. I want to get the u dx. So let a be equals to what? X plus 1. In which case, the a dx is equals to what? 1 plus 0, which is what? 1. Differentiating this is what? 1. Differentiating this is what? 0. Okay. Now, what happens next? Since a is equals to x plus 1, it implies that what? U is going to be equals to what? U is going to be what? 3a squared. Okay. If u is equals to 3a squared, the u, the a, in that case, is going to be what? 6a. That's 6a raised to power 2 minus 1, which is 6a raised to power 1, which is what? Which is 6a. That's for the u, the a. Now, for the u, the x now. The u, the x formula will now be what? The u, the a times what? The a, the x. Which is, the u, the a in this case is what? The u, the a is what? Is 6a. The u, the x is what? The a, the x, I mean, is what? Is 1. So, that means the u, the x is what? 6a. Where a is what? X plus 1. I'm going to have this as what? 6 into what? X plus what? X plus 1. Now, for v, the v dx, straight up, the v dx is what? 1 minus what? 0. Differentiating this is 1. Differentiating this is what? 0. In which case, I have my dv dx is what? 1. Let's now apply the u dx, which is this, and the v dx, which is this, into our formula. Now, recall, product rule formula is what? dy dx equals to what? Equals v du dx plus what? U dv dx, which implies that what? V is what? X minus 1 times du dx, 6 into x plus 1. Then, from the formula, plus u is what? U is what? 3 into bracket x plus 1 squared. Okay? And dv dx is what? Is 1. In which case, I have it as what? Can bring this 6 to the front into what? X minus 1 into what? X plus 1. Then plus what? 3 into what? X plus 1 squared. Factorizing, I can bring what out? I can bring x plus 1 out. Which remains what? 6 into what? X minus 1 for this one. Then plus what? 3 into what? X plus 1. Okay? So, for this case, I can continue solving. We now becomes x plus 1 into what? 6x minus 6 plus what? 3x plus what? Plus 3. Okay? Which now becomes x plus 1 into, that's 9x minus what? Minus 3. Okay, I can bring 3 out. That becomes what? 3 into x plus 1 into what? X, into what? What means after bringing 3 out is what? 3x minus what? 1. So this is the answer. Example. Given that y is equals to x squared into bracket 3x minus 1 all over x plus 1 whole square, find the y dx. Now in quotient rule, the formula is given to us as the y dx equals v du dx minus u dv dx over v squared. Okay, which in same vein, v and u must appear in my solution. Now to solve this, I will have to represent this with u and represent this with what? With v. Okay, the converse is not allowed because of this what? This minus, and because we are dividing also. So in this case, I'll find the u dx, I'll find the v dx, then I'll apply it into my formula and I'll get my the y dx. Now let u be equals to what? X squared into what? 3x minus 1, and let v be equals to what? X plus 1 all squared. In which case, for u to find u dx, my u is in product form. Okay, so I'm going to use product rule to what? To solve for u. So I would like that. Let this one be a, let this one be what? Be b. Now a is equals to what? X squared, and b is equals to what? 3x minus 1. For the a dx is what? 2x, and the b dx, in which case, is going to be what? 3 minus 0, okay, which is 3. So, using product rule to solve for the u dx, the u dx will be what? A the b dx plus what? B the a dx, which is now going to be equals to what? Is going to be equals to a is what? A is x squared into the b dx is 3 plus b is what? B is 3x plus 1 minus 1, I mean, and that's for b. The a dx is what? 2x. Okay, on solving, we have our du dx. Du dx will be equals to what? 3x squared. Okay, plus what? 6x squared minus 2x. That is my du dx. For the v dx in this case, for the v dx, I have to use function of function or chain rule. So let's say this is c. Okay, you say let c be equals to what? X plus 1. Okay, in which case the c dx is equals to what? 1. Okay, the c dx is equals to what? Is equals to 1. From there, since c is equals to x plus 1, then v is going to be what? C squared. Okay, we now imply that what? The v dc is equals to what? 2c. That's 2 times c raised to 2 minus 1 in that case. Finally, the v dx is going to be what? The v dc times what? The c dx, which is now equals to what? Which is now going to what? Where are the v dc? The v dc is what? 2c. The v dx is what? 1. Okay, which is what? 2c. And our c from the question is what? C, x plus 1. That becomes what? X. 2 into bracket what? X plus what? 1. So that is for the v dx. The v dx is what? 2 into bracket x plus 1. While the u dx is what? 3x squared plus 6x squared minus 2x. Okay, which I can get, I can combine this together and get it as what? 9 what? 9x squared minus 2x. Okay, so that's for the u dx, that's for the v dx. Let's now apply that into our formula to get what? The y dx. Where v is what? V is what? V is x plus 1 all squared. All squared. And the u dx. The u dx is what? 9x squared minus 2x. Then minus u is what? U is x squared into 3x minus 1. Then times the v dx is what? 2 into bracket what? X plus 1. Then over what? Over v squared. Where our v is what? Our v is x plus 1 squared. all squared. So after solving, we get x into brackets x plus 1 into brackets x minus 9x minus 2, then minus 6x squared plus 2x all over x plus 1 all cubed.